Welcome back, students. Am I audible? Okay.
Yes, sir.
In the last class, or at the end of the last class, we discussed the procedure for overlap save method. Okay. Now, what is overlap save method and how is it different compared to overlap add method? We discussed all those points in the previous class. And I had written a problem statement. We had decomposed this longer duration input sequence into different segments of data record. Okay. Anyway, we'll be doing that. But in today's class, we'll be solving couple of problems. Okay, two problems. This one will be using circular convolution to obtain the output of a linear filter. In the next problem, we'll be using DFT and IDFT. Now, for both the problems, to obtain the output of a linear filter, we'll be applying overlap save method. Okay. So, for a linear filter, impulse response h of n is defined as 1, 2, 3, 4, and the input is defined as 1, 2, 1, minus 1, 3, 0, 5, 6, 2, minus 2, minus 5, minus 6, 7, 1, 2, 0, 1. Okay. Now, we need to obtain y of n, which will be convolution between the input and the impulse response. Linear convolution between input and impulse response by using overlap save method. And we need to use 6-point circular convolution. So whatever operations we'll be doing, all of them will be in the time domain itself. Okay? No need to convert time domain to frequency domain by applying DFT and IDFT. So first step, in the very first step, impulse response, the given impulse response is of length 4 because there are 4 samples 1, 2, 3 and 4. Okay. Capital N is equal to 6 because we'll have to apply 6-point circular convolution. We'll have to use 6-point circular convolution to obtain the linear filter. So we need to extend the length of this impulse response to make its length equal to 6, and that is done by padding L minus 1 zeros. N is 3, so 3 minus 1, 2 zeros will be padded to make its length equal to 6. Okay. Now this is for impulse response. Now the first segment of data from x of n here, because we will not be having any previous sample to consider, and according to overlap save method, L samples has to be taken from the input, but m minus 1 zeros are to be padded to it. M minus 1 zeros are to be padded or included at the beginning of this sequence itself. So for this problem, m is 4, 4 minus 1, 3 zeros. 3 zeros will be padded at the beginning of the first segment of the data block. Okay, and for the remaining samples, remaining L samples will be taken from the input. So first 3 samples will be taken from the input, and those are 1, 2 and 1. And likewise, for the second block of data, last m minus 1 samples from the previous data block will be taken as the first m minus 1 samples of the next data block. Previous data block compared to x2 of n is x1 of n, and m minus 1 samples, last m minus 1 samples will be 3. Those are 1, 2 and 1. They will be taken as first m minus 1 samples of the next data block. So 1 to 1 will be first 3 samples in the next data block, and remaining L number of samples will be taken from the input sequence. So L is 3, the next 3 samples minus 1, 3 and 0 will be taken from the input. And this continues till we complete all the samples in the input sequence. Okay. Last m minus 1 samples from the previous data block will be taken as first m minus 1 samples of the next data block, and the remaining 3 samples will be taken from the input 5, 6 and 2. And likewise, it's 4 of n 5, 6, 2, which are the last m minus 1 samples here, will be first m minus 1 samples in the next block. The next L number of samples are minus 2, minus 5, and minus 6. Okay. Next, for the fifth data block, minus 2, minus 5, and minus 6 will be the first m minus 1 number of samples. 7, 1, and 2 will be the L samples taken from the input. Next, it's 6 of L, 7, 1, 2 will be the first m minus 1 samples. 0, 1. There are only 2 samples left in the input sequence. So to make its length equal to 6, we'll pack one more 0 to it. Now the length of the last segment of data is 6. Okay. Now on these segments of input and the impulse response, we'll have to apply 6-point circular convolution. And the most convenient method of applying circular convolution is by using matrix method. Okay. So to obtain y m of n, we'll have to perform circular convolution, or to be precise, 6-point circular convolution. H of n, 6-point circular convolution with x m of n. M index is varying from 1 to 6 because there are 6 segments of data here. Okay. Now n cross n matrix, we take it for h of n because for all the calculation, h of n can be kept constant. You can just change the input segment and keep on multiplying. Now in this way you can save a lot of time. Okay. So we'll write the n cross n matrix for this. And the sequence is 1, 2, 3, 4, 0 and 0. Now each row in this matrix represent the time reversal or circular folding of the sequence and shift of those circular folding that we incorporate in the concentric circle method. Okay. Next, 0, 1, 2, 3, 4, 0. This will be pushed one position in the up. 1, 2, 3, 4. Last sample will be pushed up. 0, 0, 1, 2, 3. Next, 3, 4, 0, 0, 1, 2. Next, 2, 3, 4, 0, 0, and 1. So for 6-point circular convolution, this will be the 6 cross 6 matrix representing one of the sequence being circularly folded and subsequently shifted for every iteration by one sample in the anti-clockwise direction. Now this sequence, if we multiply this matrix with the first segment of data, which will be 1, 2, 1, will get a sequence. Now this sequence will be y1 of n, the first output block. Okay. Multiply those two and add the corresponding values. Okay. Anyway, first 3 samples are 0, so 1 multiplied with 0 and 0 will be this one. So 4 into 1 plus 3 into 2 plus 2 into 1. So it will be 4 plus 6 plus 2, 12. First sample will be 12. Likewise, multiply each of the row with the column and then write the sample values. Okay. So first output data will be 12, 11, 4, 1, 4, and 8. This will be the first output block. We'll list all those output blocks here. Y1 of n will be equals to 12, 11, 4, 1, 4, 8. This is the first output. Okay. Now, am I audible? Yes or no? Okay. Are you all following this? Okay. Now Now to obtain the second output block, we'll have to perform circular convolution between this impulse response and the second segment of data. Second segment, which is 1 2 1 minus 1 3 0. So to do that, you just keep this matrix as it is and change the second matrix 1 2 1 minus 1 3 0. Now multiply this matrix with this column so that we will get the second block of data. After performing matrix multiplication, we get 6, 16, 8, 11, 12 and 7. 6, 16, 8, 11, 12 and 7. This will be the second block of data. Y2 of n equals to 6, 16, 8, 11, 12 and 7. Okay, and likewise, you keep on doing this for all the segments of input. For to obtain y3 of n, perform circular convolution between the impulse response and the third segment record, which is minus 1, 3, 0, 5, 6 and 2. Minus 1, 3, 0, 5, 6 and 2. If you multiply these two, we'll get 41, 31, 11, 10, 28 and 29. So y3 of n will be 41, 31, 11, 10, 28, 29. Next, to obtain y4, y4 of n data segment is 5, 6, 2, minus 2, minus 5, minus 6. Okay. Y4 of n. You multiply all those sequences. After multiplying these two matrices, we'll get the fourth segment of data, which will be minus 30, minus 22, 5, 14, 21 and minus 4. Okay, so likewise 30 minus 22, 5, 40, 21 minus 4. Okay, next y5 of n. To obtain y5 of n, multiply this matrix with the fifth segment, which is minus 2, minus 5, minus 6, 7, 1 and 2. Okay. And the result for this will be 33, 1, minus 14, minus 28, minus 23 and 1. So 33, 1, minus 14, minus 28, minus 23 and 1. Likewise, for the last segment, y6, 7, 1, 2, 0, 1, 0. And for this, the output will be 0, 1, 2, 3, 4, 0, 0, 1, 2, 3, 4, and 0. Okay? Now, is this okay? Now we'll have to combine of these output blocks. We'll have to combine all of these output blocks so that we'll get the overall output of the system y of n. Now to combine overall output blocks, what did we follow? What was the procedure? How to combine the output segments to get the overall output of the system in overlap same method? From each of these output segments, we'll have to discard first m minus 1 number of samples. First m minus 1 number of samples are to be discarded and remaining samples are to be retained as it is. So from the first output segment, first m minus 1 samples are m is 4, first 3 samples 12, 11 and 4 will be discarded and 1, 4 and 8 will be retained. Likewise, from the second output segment, first m minus 1, that is 6, 16 and 8 will be discarded. The remaining 3, 11, 12 and 7 will be retained. Okay. From y3 of n, first m minus 1 number of samples, 41, 31, 11 will be discarded. The next 3, 10, 28 and 29 will be retained as it is. From y4 of n, first m minus 1 number of samples will be discarded. The next 3 samples, 40, 21 and minus 14 will be retained as it is. Okay. Next, from y5 of n, first m minus 1 number of samples, 33, 1 minus 14 will be discarded, minus 28, minus 23 and 1 will be retained. From y6 of n, first 3 samples will be discarded and the next 3 samples, 3, 4, 0 will be retained. Okay. Is this fine? Are you all able to hear me? Yes. Now, is this correct? Yes or no? Yes or no? What should be the total length of the output y of n? Length of the output for linear convolution. Now, whatever we did here, whatever we obtained y of n, it will be the linear convolution between input and impulse response. What will be the length of linear convolution sequence? It will be length of sum of two sequences minus 1. Okay. How many samples are present in the input? In the input we have 17 samples. Okay. And how many samples are there in the impulse response? In the impulse response, we have 4 samples. Okay, 17 plus 4, 21 minus 1. So 17 plus 4, 21 minus 1 will be 20. Now, do we have 20 samples in the output? Do we have 20 samples? Yes or no? In lieu of this, last sample value is 0. So this is just effectively, even if you include 0, do we have 20 number of samples? In the output, we should be having 20 samples. Are we getting it? Yes or no? Then what seems to be the problem? What seems to be the problem? Can somebody tell what did I write y6 of n? We had written y6 of n here, right? What was y6 of n? What did I write y6 of n? 1, 2, 3, 4, 0, 0, 0, 1, 2, 3, 4, 0, 0, 0, 1, 2, 3, 4, 4, 0, 0, 1, 3, 4, 1, 2, 4, 0, 0, 1. This was the n cross n matrix of impulse response. X6 was 7, 1, 2, 0, 1, 0. When you multiply these two, what will we get? First sample will be 7. This will be 0, this will be 0, 0, 3. 7 plus 3. 10. Next value will be 14 plus 1. 15. 15 plus 4. 19. Second sample will be 19. Next will be 21 plus 2. 23 plus 2. 25. Next sample will be 25. How is it? Okay. What did I write? Y6 of n name पर देता है. It has to be, you just make the correction. Instead of this 10, 19, 25, I might have written 0, 1, 2, 3, 4, 0. But actual y6 of n is 10, 19, 25, and the remaining 3 samples when we multiply here. 35, 11, and 10. Okay, now according to this, if we discard the first 3 samples, that is 10, 19, 25, we remain with 35, 11, and 10. 35, 11, and 10. Okay, now tell me, how many number of samples are there? Okay, after discarding m minus 1 number of samples in each block, only taking n number of samples, last n number of samples from each output segment, we had got this sequence. Okay, how many samples are there here? We have 18 number of samples. Okay, in the output, whatever we are obtaining, we have 18 number of samples. How many samples are to be there actually in the linear convolution output? We should be having 20 number of samples. Okay. First tell me, are you all following? Yes, sir. Did you all understand what is happening here? If we perform linear convolution, which is the output of a linear filter, on this impulse response and on this input, the output length, whatever output we obtain, it should be of the length 20. There should be 20 samples in the output sequence. Because in the input we have 17 number of samples, and in the impulse response we have 4 number of samples. 17 plus 4 minus 1 should be the total length of the output, 20. But we performed circular convolution between these two, input and impulse response. We mimic the operation of linear convolution itself. Okay, but in the output sequence, whatever we got, how many samples are we getting? We are getting 18 number of samples. Okay, now how to correct this? Now that means whatever we obtain is not complete. I'll not say wrong. All the sample values are correct, but it is incomplete. The result is incomplete. Now, how to complete this? That's why I said in the other class, in the previous class, it is always good practice to check the length of the output sequence, whatever we obtain, either after applying or using overlap add method or overlap save method. Okay, particularly this problem will not encounter in overlap add method. Will be having this in overlap save method itself. What might be the reason? Now the reason is, first thing will be padded zeros at the first segment of the block, and in the output segment will be discarding these m minus 1 number of samples. So there will be loss of data. And at the end, we have included 0, 1, 0 only once, and the output due to this will be discarded. First m minus 1 number of samples in the output segment, because of the input sequence x6 of n are discarded. So there will be a loss of data here. Okay, and this can be overcome by including one more sequence, that is x7 of n. We can include x7 of n. Now input segment, taking one more additional input segment, follows the same rule. First, in this sequence x7 of n, first m minus 1 number of samples will be taken from the last m minus 1 samples from the previous input. Last m minus 1 samples here are 0, 1 and 0. 0, 1 and 0. And remaining n samples are to be taken from the input. But do we have any more samples in the input? We have covered till 0, 1. Okay. We do not have any more samples in the input. So to make its length equal to 6, we'll simply pad zeros. So x7 of n, 0, 1, 0, 0, 0, 0. This will be the additional segment to compensate for the loss of data. Now we'll have to perform circular convolution between h of n and this. The rest of the procedure is same. y7 of n will be equals to circular convolution between h of n and x7 of n. Now whatever output will get, that will be written here. That is, with the rest of the output segments. With the rest of the output segments. In this case, it will be 1, 2, 3, 4 and 0. 1, 2, 3, 4 and 0. Now from this output segment, the same procedure. First m minus 1 number of samples will be discarded and the remaining L samples will be considered for the output. And in this, the last part is 0. So after 10, the two non-zero values, 3 and 4, will be included. So the output is 1, 4, 8, 11, 12, 7, 10, 28, 29, 40, 21, minus 14, minus 28, minus 23, 1, 3, 1, 35, 11, 10, 3 and 4. So total length of this output sequence is 20. Understood? Understood? Any doubts, any questions? We'll consider one more problem on this overlap save method. for which the impulse response h of n is defined as 1 and 2, and the input sequence is defined as 1, 2, minus 1, 2, 3, minus 2, minus 3, minus 1, 1, 1, 2, and minus 1. The same set of impulse response and input that we use for overlap additive. Okay. Now we'll have to obtain the output y of n by using DFT and IDFT method. Okay. Now, how many point DFT and IDFT has to be used? They are not specified. Okay. Now for that, we'll be taking the help of length of the impulse response. Length of the impulse response is 2. So based on this, we'll be using capital N, which will be 2 to the power n, and in this case, it will be equals to 4. So for m equals to 2 and n equals to 4, L will be equals to 3. L will be equals to 3. Okay. Now this means in the first data block, in the first segment of data, first m minus 1 number of samples will be 0. M is 2, 2 minus 1. One sample will be 0, and remaining 3 samples will be taken from the input, and those will be 1, 2, minus 1. Okay, and like this, x2 of m. First m minus 1 samples in x2 of m will be taken from the x1 of n, last m minus 1 number of samples. Last m minus 1 number of samples are only one, which is minus 1. And the next 3 samples will be taken from the input. 2, 3, minus 2. x3 of n. Last m minus 1 number of samples will be taken from the previous block, and remaining n samples will be taken from the input. Minus 3, minus 1, 1. Okay. Next, x4 of n. Last m minus 1 samples will be taken from the previous sample, and remaining L samples will be taken from the input. So 1, 2, minus 1. Now this completes all these samples from the input, and the impulse response h of n, which is of length 2, will be extended to length 4 by padding L minus 1 number of zeros. 3 minus 1, 2. 2 zeros will be padded to the impulse response to make its length equal to 4. Okay. Now on these, we'll have to apply 4-point DFT on each of these sequences. Multiply those 4-point DFTs and apply 4-point IDFT on each of those sequences. Okay. Now let us do this. Okay. Let us solve this problem in detail. First, to obtain 4-point DFT of the impulse response, we'll have to multiply the Whittle factor matrix. This is the 4 cross 4 Whittle factor matrix. Now this has to be multiplied with the impulse response sequence. 1, 2, 0, 0. Okay. So 4-point DFT that will obtain is 1 plus 2, 3, 1 minus 2j, 1 minus 2 will be minus 1, and 1 plus 2j. This will be the 4-point DFT of the impulse response. Let us write that here itself. H of 4-point DFT will be 3, 1 minus 2j minus 1, 1 plus 2. Okay. Now Again, we use the same 20 factor matrix. Instead of the impulse response, put the first segment of data, which is 0, 1, 2, minus 1. First DFT point will be equals to 2. Second DFT point will be equals to minus j, minus 2, minus j. Okay, so it will be minus 2, minus 2j. Next data point will be 2, next will be minus 2 plus 2j. So this will be the 4-point DFT of the first data record. 2 minus 2 minus 2j plus 2 minus 2 plus 2j. Okay. So next, for second data record, which is minus 1, 2, 3, minus 2, the 4-point DFT will be 2 minus 4 minus 4j, 2 minus 4 plus 4j. So x2 of k, 4-point DFT of the second segment, x2 of f will be 2 minus 4 minus 4j, 2 minus 4 plus 4j. Next, this will be done for third segment as well. Third segment's input data are minus 2, minus 3, minus 1, 1. Okay. And its 4-point DFT will be minus 5, minus 1 plus 4j, minus 1, minus 1, minus 4j. So this will be minus 5, minus 1 plus 4j, minus 1, minus 1, minus 4j. And likewise, for the last block of data, 1, 1, 2, minus 1. Okay? It's DFT, 4-point DFT of the last data segment. 4-point DFT of the last data segment will be 3 minus 1 minus 2j, 3 minus 1 plus 2. It's 4 of k equals to 3 minus 1 minus 2j, 3 minus 1 plus 2. Okay. Now, on each of these 4-point DFTs, multiply those two and obtain the product y1 of k, y2 of k, y3 of k, and y4 of k. y1 of k will be the product of h of k and x1 of k, and likewise. Okay, multiply them point by point, you will be getting those 4-point vectors. And multiplying h of k with x1 of k will get 6 minus 6 plus 2j minus 2 minus 6 minus 2j. This will be the 4-point product DFT. Multiplying h of k with x2 of k will get 6 minus 12 plus 4j minus 2 minus 12 minus 4j. Multiplying x of 3 with h of k will get minus 15, 7 plus 6j, 1, 7 minus 6j. And lastly, multiplying x of 4 with h of k will get 9 minus 5 minus 3 minus 1. This will be the 4-point DFT. Now on these 4-point product DFT, you apply 4-point IDFT. Write the conjugate matrix 1 1 1 1, 1 plus j minus 1 minus j, 1 minus 1 1 minus 1, 1 minus j minus 1 plus j. This is the 4 cross 4 conjugate matrix. And multiply this with each of these four DFT values. 6 minus 6 plus 2j minus 2 minus 6 minus 2j. And after multiplying these two matrices, divide all the results by 4. You will get a discrete time sequence. And for the first value, discrete time sequence will be minus 2, 1, 4, and 3. Minus 2, 1, 4, and 3 for the first product. For the second product, phi2 of n, it will be minus 5, 0, 7, and 4. For y3 of n, it will be 0, minus 7, minus 7, minus 1. And lastly, for y4 of n, it will be minus 1, 3, 4, and 3. Okay. Now, if these are the output blocks, how to obtain the total output? Total output y of n will be given by combining these four. And from these four, first m minus 1 number of samples, 2 minus 1, 1. One sample in each of these, first one sample in each of these are to be discarded, and the remaining has to be retained. So from the first output block, 1, 4, 3 will be retained. From the second output block, 0, 7, 4 will be retained. And from the third output block, minus 7, minus 7, minus 1 will be retained. And from the fourth output block, 3, 4, 3 will be retained. Okay. Now, is this correct? Is this correct? How many samples are there in the output? There are 12 samples. How many samples are expected to be in the output? According to the length of the impulse response and input, there should be at least 13 samples. But here we are getting only 12 samples. Now that is because loss of data. Now to compensate for this, we will have to include one more segment of input. One more segment of input. Where first m minus 1 samples will be taken from the last m minus 1 sample of the previous segment. That is minus 1. And next L samples are to be taken from the input. But there are no samples left because we have covered all of them. So to make its length equal to 4, we will simply add zeros. So x pi of n is a additional input segment which will be minus 1, 0, 0 and 0. If you take 4-point DFT of this, 4-point DFT, x pi of k will be minus 1, minus 1, minus 1, minus 1 because all the other sample values are 0. Only first value will be retained, which will be equals to minus 1, minus 1, minus 1. Now this will be the 4-point DFT of the fifth segment. Now if you multiply that with the 4-point DFT of the impulse response, 4-point DFT of the impulse response, then we'll get what will be the product DFT. All the sample values are minus 1 in the 4-point DFT. So product DFT and amplitude y5 of k will be negation of all the values in the impulse response, which will be minus 3, minus 1 plus 2j plus 1, minus 1, minus 2j. This will be the product DFT. And if you take 4-point IDFT on this, you will get the fifth data segment, which will be equals to minus 1, minus 2, 0 and 0. Minus 1, minus 2, 0 and 0. And from this data segment, we'll have to discard the first m minus 1 number of samples, that is minus 1, and retain all the other samples. And the last two samples are zeros. So we'll just include the non-zero value, which is -2. Now this result is complete. Understood? Any doubts, any questions? When is your IA? First IA? 8, 9, 10. Digital signal processing is in on the first day itself, on the 8th. Okay. Madam has put out the uh, schedule for the internal assessment as well as the syllabus for each subject. Hmm. Syllabus for digital signal processing is module 1 complete, and from module 2 the first part of module 2, which covers how to use DFT and IDFT for linear filtering, that is how to obtain the linear convolution output by using DFT as well as linear circular convolution and linear filtering of long data sequences. Now both of these methods, overlap add method and overlap save method. So whatever we have covered till today will be included for first aid. Okay. So with this problem, we have finished the first part of module 2. Module 2 had two parts. First part wherein we studied how to use DFT and IDFT for linear filters. And in the second part, we'll be studying an important algorithms called as FFTs, fast Fourier transforms, which will be starting from tomorrow's class. So, any doubts, any questions so far? Yes? And for parallel batch students, the content of the syllabus is same. Okay? First one complete module, and in the second module, till overlap add method and overlap save method. Okay, the portion will be same for regular students as well as parallel batch students. Till linear filtering of long data sequences, which will include both overlap add method and overlap save method. So we will conclude for today. We'll meet with the fast Fourier transforms in the next class.